Assalamualaikum and a very good morning to Sir Haslan bin Mansha. My name is Fazira Natasha binti Kafar and I'm going to present for the coursework of MTES1114 Basic Geometry for the coursework of Solving Analytic Geometry. So the first one is the list of contents. Let me read the list of contents first. 1.0 is the introduction, 2.0 is the analytic geometry, conic section, graph and equation using geometry sketchpad, geometer sketchpad, 3.0 solving analytic geometry using geometer sketchpad, GSP, and lastly 4.0 is the conclusion. So the first one is the introduction. The first field of mathematics to benefit from the new language of equation was geometry. Analytic geometry are used to represent and solve problems in geometry. The importance of analytic geometry is that it establishes correspondence between geometric curves and algebraic equations. According to Apollonius of Perga, known by his contemporaries as the Great Geometer, foreshadowed the development of analytic geometry by more than 1,800 years with his books Conics. He defined a conic as the intersection of a cone and a plane. Using Euclid's results on similar triangles and on seconds of circles, he found a relation satisfied by the distance from any point P of a conic to two perpendicular lines, the major axis and the conic, and the tangent at endpoint of the axis. Last but not least, the four basic types of conics are circle, parabolas, hyperbolas, and also ellipses. Thus, in this coursework, we will go through the application of each type of conic and solve the real-life problem using GSP, Geometer Sketchpad. So what is Geometer Sketchpad, or we can call it as GSP? So GSP is one of the dynamic mathematics software that provides opportunities for students to investigate it and discover mathematics concepts, in particular geometric concepts. So GSP empowers students to use their ability to create graphical representation, which will enable them to develop their mathematical thinking skills, concept, and also understanding. Moreover, Lester 1996 found that GSP increased students' achievements in geometry. Therefore, with the help of GSP, it can enhance students' understanding of conic section. So let's move to the second content, which is 2.0 analytic geometry conic section for the graph and equation that we use in GSP. So the first one is circle. So what is circle? Circle is formed when a plane cuts the cone at right angle to its axis. So the standard equation and parameters of circle is x minus h the power of 2 plus y minus k power of 2 equals to r squared, where h and k is the center of the circle and r is the radius. Second one is ellipse. What is ellipse? Ellipse is formed when a plane cuts the cone at an angle with the base. So the standard equation for ellipse is x minus h squared divided by a squared plus y minus k squared divided by b squared equals to r squared. R squared must be equal to 1 in order to make an ellipse. Next is parabola. So what is parabola? Parabola is formed when the plane cuts the cone parallel to the side of the cone. So the standard equation is x minus h squared equals to negative 4p y minus k. Last is hyperbola. What is hyperbola? Hyperbola is formed when a plane intersects at a double right circular cone at an angle such that both halves of the cone intersects. So the standard equation of hyperbola is y minus k squared over a squared plus x minus h squared over b squared equals to r squared. Same goes with the ellipse equation. R must be equal to 1 in order to have hyperbola conic sections. So the third content is solving an analytic geometry using GSP. This is where we apply a real life problem in order to make in order to know the equation of analytic geometry that we use using GSP. So the first one is application of ellipse problem solving, which is American football ball. So the first step is we form an ellipse equation, which is x minus h squared over s squared plus y minus k squared over b squared equals to r squared, and then we interpret it till it get y equals to fx, and then we plot the function. And step 2, we insert the parameters till it have same shape as the American football ball. Here we have k equals to 0, h equals to 0, so we know that the center is 0, 0. P equals to 1.85, A equals to 4.30, and R equals to 1. R must be equal to 1. So step 3, we plot the function fx, and then step 4, we insert the parameter to find the equation from the equation from an ellipse. And then we have the equation of the American football ball, which is x squared over 4.30 square plus y squared over 1.85 square equals to 1. The second problem solving is also an ellipse problem solving, which is we apply in MTES commercial banks. It is shaped like it is a building that is shaped like a ellipse. So same goes to the first problem. First step is we form an ellipse equation, and then we get the y equals to fx. Step 4, we insert the parameter until it looks like an ellipse shape of the Mauritius commercial bank shaped building. And then here we have a parameters of center is 0, 0, p equals to 1.85, a equals to 3.78, and r equals to 1. And therefore the equation for the Mauritius commercial bank is x squared over 0.24 square plus y squared over 1.85 square equals to 1. And the third problem solving is the water fountain. So water fountain is shaped here like a parabola. So first step is we form an parabola equation. So our parabola equation is x minus h squared equals to negative 4p y minus k. And then we solve it to make y as a subject, and then we get y equals to fx. And then step 2, we insert the parameter. The k is 0 while h is negative 2, which is we know that the center is negative 2, 0. P equals to 0.30. So we insert the parameters, and then we solve for the equation for the water fountain like shaped parabola, which is y equals to x plus 2.0 square over 1.2. The fourth problem solving is Eiffel Tower. So it is also same. It is shaped like a parabola, the bottom of the Eiffel Tower. So first step, we form a parabola equation, which is y equals to k minus x minus h squared over 4p. And then we insert the parameters until it's shaped like a parabola for the bottom of the Eiffel Tower. And then we plot the function, and then we got the equation for the Eiffel Tower, which is y equals to 2.45 minus x plus 2.0 square over 10.8. And last but not least, for the problem solving of hyperbola, which is 10 hourglass, first step is we form a hyperbola equation also, which is y minus k square over a square minus x minus h square over b square equals to 1. And then we solve until y is the subject, and then y equals to k plus minus square root of a square plus a square x minus h square over b square. And then the second step, we insert the parameters. Here we have k equals to 0, h equals to 2, which is we know the center is 2, 0. And a equals 0.5, b equals to 0.4. Step 4, we insert parameters, and then finally we get the equation for sine hourglass, which is y equals to plus minus square root of 0.24 plus 1.56 in a bracket x minus 2.0 square. And last content, last but not least, is 4.0 is the conclusion. So to conclude, conic sections are in many objects that we use in our everyday life. They are also in objects we ride in and sometimes the buildings we go in. Many things are shaped in parabolas, circle, ellipse, and hyperbolas, and because of the way things are shaped, gives us the opportunity to use the items correctly because they are made correctly in the right shape. Therefore, this coursework has shown how GSP can enhance student understanding in interpreting eccentricity and connexation both visually and numerically. GSP is a very useful and effective tool for both teachers and students. So GSP changes the way mathematics is taught. It is clear that with GSP, students are able to create graphical representation of eccentricity and connexation. Last but not least, GSP enables us to construct graphical and numerical representation together. That's all from me. Thank you.